Interception and collision is the subtopic we are going to handle under still resultant and relative motion. Okay, interception and collision, if these two bodies, assuming this is the body and this is the body, if they are moving, this is what we call collision. But it's as simple as that this body is intercepting this from moving. That's why we say you either collide or intercept each other. Okay, consider two bodies A and B with velocities VA and VB respectively. For collision, it means that the distance between the two A and B is 0. Yes, if I have this body and this, for them to collide, you see that here there is some distance between them. But when they collide, it means the distance between them is 0. So meaning they are touching each other. So that's the idea. Recall that we say a displacement of A relative to B is given by this. We get the distance of A, the displacement of A, and the displacement of B. But because they are, for collision to occur, it means that there is no any displacement between them. They are at the same point. It means that now this is equal to 0, meaning that this minus this is also 0. So when R, it means that if this and this are 0, it means that this is equal to that. If you subtract into same things of the same size, it means that you are going to get a 0. Note that the distance between A and B is given by magnitude of A R B T. So that's the idea here. So if distance is 0, it means that even this is going to be 0. Alternatively, this is how you can handle it. If you have A and B, remember this is moving at velocity A and this one at the velocity B. For them to collide, it means that they are going to meet at a certain point. So if this is moving velocity A and this is velocity B, it means that for them to collide, they will form a given triangle. If there are two bodies, they are going to form a given triangle there, as you see. So if for them to collide from the initial point, they have to meet there. And so they will be forming a triangle there. And if that triangle is there, it means that we can use the sine rule. Sine of this over sine of this is equal to this over sine of this, which will be the same as the BC over sine theta, then the SC over sine beta. As simple as that. Note, the velocity of A relative to B, ABB, is always along AB. If now I get the velocity of A relative to B in that direction, so it means that now our ABB is going to be parallel here, or it is going to be there. Meaning that this shows that they are parallel. This one a constant, certain scalar. That's how we show that two are parallel. So the time taken for collision, it means that the velocity, the zone rest of A at B if B is at rest. It means that it's going to be the distance AB over the resultant velocity, which is going to be the relative velocity of A relative to B, or B relative to A. Say you get the magnitude, of course. Okay, magnitude of this. Of course, distance can't be negative. Okay, to show that collision occurred, then we show that time is consistent, the same, constant means the same in all directions, i.e., ij. If they tell you that, show that these two particles will collide, equate them, get the time, and then show that time is consistent in all the directions, the I, J, and K. Let us use an example here. The position vector of A is this, and B is this. The position vectors are for particles with velocities this and this. Show that collision will occur if velocities are maintained. It means that if the velocities are constant. So for them to collide, it means that the displacement of A at any time is equal to the displacement of B at any time. So what does it mean? It means that now RA at any time is equal to RB at any time from here. Now you know how we get RA? I mean RA at any time. You get R initially, then plus the velocity of A times T. It has to be the same as the position vector of B plus the velocity of B at any time. So we have the collision vector of this initial, which is 5, -3, then 4, then plus the velocity of A, which is 2, 5, 3 into t, should be equal to initial position of B, which is 7, 5, negative, then plus the velocity of B, which is -3, -15, then 18, then times t. And from there, we just form equations. So that we shall be having 5 plus 2t equaling to 7 minus 3t. Okay, which I can simply write as this will be 2t by 2t plus 5 equal to, when I take this side and then I bring this side. So that's what I'm going, but let me leave it at once because I know people now can see what is going on. So this is, let me, instead of writing 2 plus 3, I think that one is not so high. So from there, see, when I bring this side, I'll be having 5t equaling 2. This is 7. When I take this side, I'll be having a 2. And from there, I can start. My 2 is going to be 0.4. Okay, then let us take another equation. When we take -3 now, plus 5t, it should be equal. If these are equal, it means that the i's notation is equal, the j's notation are equal, then also the k's. So that will be 5 minus 15t. Bring t this side, we have 20, t equaling to 8. And so our t by 4, 2 by 4, 5, which would be 2 over 5, it's still 0.4. Are they seconds? Okay. Seconds. So it's that now, in the ith notation, this is our jth direction. Then let us also try it at k, the kth direction. It means that now our 4 plus 3t will be equal to -2 plus 18t. Okay, bring this, we have 6 equaling to this side, we are having 15t by 3, 2 by 3, 5, and somewhere it is going to be 0.4 seconds. I think we start, it's consistent, and therefore we said, since t equaling to 0.4 seconds is consistent or the same in all directions, comma, then collision will occur. As simple as that. So that's how we show. I wish you well. Don't forget to subscribe to the channel.